Okay, I need everyone's attention up front. We're going to be talking about completing the square today. Chris? And our goal today is students will be able to solve a quadratic by rewriting as a perfect square binomial. We will talk about what a perfect square binomial is. And solve it by taking square roots. We have a couple of methods of solving a quadratic, but they only work in certain situations, Danny. Okay, we can solve a quadratic that factors. Sade, Sophie. We can solve a quadratic that factors. Or we can solve a quadratic that has no x term. That's the only types of quadratics we can solve so far. Completing the square will solve any quadratic we're working with. Any at all. So I had you do a couple of problems on the warm-up that are going to be related to what we're talking about today. Daniel. Oh, it looks like your headphone was in. Never mind. It was just the angle I was at. Sorry. The angle I was at made it look like it was still in your ear. They do. Okay, so we have this that we're going to factor. And the reason we're factoring is because it will help us find a pattern that will help us solve these completing the square problems. So when we factor, we do the box method. We multiply first times last. And we find the numbers that multiply to be 36, but add to be negative 12. So what numbers should we use? Negative 6 and negative 6. This is box method. It's going to help us look for a pattern that we're going to use when we're completing the square.
I wonder what that was.
So we've set up our box. What do we do next with the box method?
Find the
Greatest common factor. Sade and Soki. Write it down. Daniel, Edgar, and Danny.
Why?
We just found Lindsay. We just wanted
Okay, greatest common factor in the top row is x. Bottom row is negative 6. First column is negative 6. And
How is that negative 6?
sorry,
That's negative. I mean, that's
sorry, I was skipping to this part. Thank you. Is x, then negative 6. So we get x minus 6 times x minus 6.
I thought they had above the
Nope, just the first one has to be negative. Okay, so then we need to rewrite it just as Edgar and Hannah were saying. We can rewrite this as x minus 6 squared. This right here is called a perfect square binomial.
Are we going to do that little cheat chart?
No, because it's not equal to 0. So this is called a perfect square binomial. So again, we're going to look for a pattern. If we took this same problem and we had just x squared minus 12x with nothing there, we don't know the 36, and we wanted to pick a number so that we could write it as a perfect square binomial.
Wouldn't you just find something that adds up to negative 12?
Okay, but it has to be a little more specific than that. So we're trying to find these two spots, looking at a pattern for this. So Edgar said, well, we're going to find something that adds to be negative 12, but we need to be more specific. Specifically, what kind of something that adds to be negative 12? Okay. Because the only way we got this perfect square binomial was if these were the same. Silky, will you move away from Sade, please?
Right there?
No. Farther away so you can't hold a conversation with her.
Right here.
Okay? How about over here? The middle table. We just need an empty seat.
Sorry.
You can just put that on my desk. Okay? So, we needed it to be the same number so that we could write it as a perfect square binomial. So what kind of numbers are we trying to see if they add to be negative 12?
Negative 6.
The same number. So negative 6 plus negative 6. What is adding the same number together really the process of, though, if I do?
Multiplying
It's
it by
the same
2.
as multiplying. Okay, but we're trying to do opposite. If I multiply 12 by 2, I'm not going to get to 6. So how do we get to 6? Divide. Okay. So if we divide this number by 2, that's how we would get this number down here. And we could just write x minus 6 instead of x plus negative 6. Yep, it's always going to be 2 because we're always looking for the same number to add together. Which is always. At least with completing the square, it's always this way.
Always.
Okay. How would I then find this number up here?
Times
Negative
it.
6 times negative 6.
Negative 6 times negative 6. Now we square it. Now if I do negative 6 squared,
Negative 36. When 36.
positive 36. So we actually had to find the perfect square binomial first and then go to 36. Now, the whole reason we looked for a pattern is so that we can skip this box method. We looked for a pattern so that we don't have to go through this whole process. We just eliminated all of that. It's not pointless. It saves you a lot of work.
No.
Okay?
Did a lot of work.
Okay? So let's try one where we don't have the answer. So, oh, shoot. I forgot to erase the 49.
It's 49.
It's 49.
Now you erased the whole problem.
It's 49. Even
49ers. Hey, who's on 60?
What the heck?
It doesn't like you.
Don't erase the underline.
There you
Fine.
It doesn't like you.
I guess it does not.
It's 49.
Okay. So, let's go through the process now, where we skipped all the box method. We're just going through the quicker process. We looked for a pattern, and we said we had to take this middle number and do what to this middle number? Divide it by 2, always. And that's what goes in our perfect square binomial. We cut out doing the whole box method. Now we don't have to do the box. We were able to just do a lot quicker step.
So it's always by 2.
Always 2.
What if you get a decimal then?
I will not give you any problems where you get a decimal.
Well, what if we find the decimal?
Then you did it wrong?
Yeah.
Yeah. So then, what did we say we had to do to get the blank spot? Okay. Square it. It's a perfect square, so negative 7 squared is 49. So the general steps are on the side. The general steps say, divide B, I put B in quotations so you know it's not part of another word. Divide B, that's the middle number, by the x, by 2. Put that in the perfect square binomial. And then you square the answer to fill in the blank spot. Fill in the second spot. So once you have the instructions written down, we're going to try one of these problems. These are the simpler form. Usually we start with the simpler forms. After we do this try problem, then we're going to do some examples where we actually solve the equation.
I need something for my mouth.
You're nasty.
What happened?
Okay.
You go back
Yeah, go back over.
Yeah.
So I thought it was like
Oh, there's nothing for
two girls, sweaty.
Okay, I need your attention back up front.
Move on. There's just one that's like.
We're ready. Edgar, we're ready. Sophie, we're ready.
I am ready.
I used to go.
I got the
Sade,
answer.
we're ready.
See, Senora.
Can I help you?
Okay.
Speak our language.
So, what is our answer for this one? So,
36.
okay, this part's 36. What about our perfect square binomial?
Back 12.
Sade, guys, we're moving on. So you need to quiet down. Divide 12 by 2.
And then you get,
You get 6.
and then you get x plus 6 squared.
Square. We need both as our answer. We need the perfect square binomial and that number. Again, this is just so we can skip the factoring. We could go through and factor this, do the box method,
Nope, let's not.
but we're trying to skip that step to go quickly to this. Because there's already enough steps when we're completing the square. So now we're going to take this and we're going to solve a quadratic equation.
I'm alright.
What?
Yes.
Oh, wait, never mind, sorry.
Are we still?
I realized I have another pencil.
Hi, YouTube.
So you guys need to quiet down again and start writing these steps down.
Right?
Oh, it's not a video camera, it's just recording the smart board only, the
I'm gonna do
iPad
that too.
and the board. Yeah. So you can't see any writing.
Is this the last
Okay.
example? That's a good one.
Our first step is to move all the variables to one side and numbers to the other side. Our second step is to do that completing the square process we just found, so find b divided by 2. Then 3, find b over 2 squared. We're going to end up with 2 blank spots instead of 1 because we have an equation, and you'll see that in just a minute. I want you to have the steps written down, though, before we start the process.
What's the last step?
There's actually 6 steps, so we're going to start part of the process and then finish writing down the steps in a
What's the
minute.
second one say? Find b over 2?
b over 2, yep.
That
So
is.
guess what? It was an h.
Math here.
So first, we had to move all the variables to one side and numbers to the other side. Usually the variables go on the left. Here are our 2 variables. Here's our number. Why are these 2 our variables?
Because they have variables.
They have an x. That makes them variables. This one doesn't, so it makes it our number. So if our variables are already grouped together on the same side of the equal sign, I just need to move that number. How should I move that? Positive 4.
Subtract 4.
Subtract 4 from both sides. Danny.
I screwed up.
He talks the number.
Okay, those cancel out. And then this is the start of the problem we just saw. So in the problem we just saw, it had a blank spot because we had to fill in a number so that we could rewrite this as a perfect square binomial. So we're going to put in that blank spot ourselves.
Wait, did we eliminate the 4?
We did. We eliminated the 4 on the left side.
And the 0?
Because we need all the variables on one side, the number on the other. We can't do this completing the square process unless it's blank over here. We need that blank spot to rewrite as a perfect square binomial. So then on this side, we can combine the 0 minus 4. What is 0 minus 4? Negative 4. Now we put a blank spot on the left so we could do that completing the square process. But now it's an equation. When I have an equation, what do we have to do with equations? That is the entire process. I guess I should have been more specific because that is correct but not what I was looking for. when we change something on an equation, on one side of the equation, what do you have to do to the other side?
Same thing.
The same thing. So if I put a blank spot here, I also have to put a blank spot over here. Because what you do to one side, you have to do to the other. It's a requirement for an equation. So now, this left side, I can do the completing the square process. This left side, we take the middle term and divide it by b, the middle term b and divide it by 2. Negative 6 divided by 2 is negative 3. That we put down in our perfect square binomial. Again, this whole purpose was to find a pattern so we didn't have to factor.
Oh, yeah.
We changed it so we didn't have to do this entire box method to get to here. So we're just skipping some steps to make it easier on us.
A lot.
A lot of steps. So then we had to fill in our blank spot. We had to square this number. If we do negative 3 squared,
9.
we get 9. So before, it didn't really matter about the 9 because we got our perfect square binomial without really needing the 9. But since we have an equation now and we had to add 9 here,
You got 9 over
we
there.
add 9 over there. That's going to change this right side. So that's why we needed the blank spot in the
So is
first
that
place.
it?
No, we are not done. This is a longer process. So now again we can combine the negative 4 plus 9 to get 5. So that was just the first 3 steps.
What?
There's
Excuse me,
3?
What? Yeah.
Wait, so there's 3 more?
Yes, there are.
Ay, marica.
Okay, so after we've done those first 3 steps, we have something we can actually solve now. We have processes that can get rid of, remember when we're trying to solve for an equation, we want x completely alone. The whole purpose of writing it as that perfect square binomial is because now we have the tools to get x alone. If I want to get rid of squared, then we square root it, just like step 4. If I want to get rid of that 3, after I square root it, we would add or subtract that number because that's the opposite. So now we're down to solving an equation, but it is different than any equation you've seen so far. It is a little bit weirder than the equations you're used to working with. But we said the next step was to square root both sides. So I'm going to write step, usually we do it on the same line, but just for notes purposes on this problem, I want to show you that it's actually a second step.
Do we have to draw?
Yes, for this problem, all the others we won't have to.
What are we doing?
So if it's squared, squared cancels with square root. They are opposites. And when that happens, it also gets rid of the parentheses. The only reason we needed parentheses is because we were squaring it. Once the squared's gone, I don't need those anymore. And on the other side,
It's just like
okay, square root 5, it's not a perfect square, so it's going to stay square root 5.
Positive and negative.
But we do have to add a special symbol now.
a negative.
Positive or negative, because
And a
we can
negative.
consider
Just say
all of our answers. In the past, you only worked with positive square roots. But we can now do the full, because we've moved on to considering the full mathematics instead of just a little piece.
Oh my lord.
So we're not quite done. Sorry, I'm just going to take a quick drink.
Go for it, girl crush.
I feel like
That's nice.
I'm getting sick, I think.
Thanks.
Ew. Okay, so we have to get rid of the 3. How would I get rid of the 3? Plus opposite operations. We'd add 3 to both sides. So now we have our x equals, which is what we were looking for. These two numbers do not combine. They are not like things. We cannot add a regular number and a square root, an irrational number. So if they don't combine, we just write them side by side. And normally we put the integer in front, the square root second. So we're going to write 3 plus or minus square root 5. Now in this particular problem, we are done.
Yes.
Okay.
Finally.
But we do still have a 6th step that we can do on some problems. So we still need to write our 6th step in.
Oh
How did
my.
we get 5? Yeah, up above we did the negative 4 plus 9. That's exactly correct.
Pay attention.
So the last step we could do, because this might not be in simplest form, we can simplify the radical. On this one, why don't we need to simplify this square root 5?
Because you can't.
We can't. It's already as simple as it can be. 5 is prime. I can't do anything else. But not every answer is going to end up with a prime number. So let's do a couple more problems. We're going to do 2 more examples. Okay, the second example, the first 5 steps are always the same of completing the square. So example 2, example 3, first 5 steps the same. It's that simplifying that can change. So we're going to do example 2 together, and then I think example 3 I'll have you try the first part on your own. And then we'll talk about the simplifying part together on example 3. So this time we're not going to be writing notes as we go through the problem. We're just going to show this is how we do it. This is the process. I always have to watch what I say because of things like that. That one wasn't bad. Sometimes you say things that aren't supposed to be bad, and students will make it into something not good. Okay, does everyone have this written down?
No,
Yeah.
I'm writing it down right now.
Yes.
I wrote it down.
Okay,
Just teach.
we need to get all the variables on one side, all the numbers on the other side. So what are the variables that we need to get together? Which ones are our variables, Danny?
B.
B what?
B squared and 20B.
B squared and 20b.
Boom.
Okay? So we need to get those together. Usually we want our variables on the left side. B squared is already on the left side of the equal sign.
So you minus 20.
So we're going to move 20 over, and as Edgar said, we're going to minus 20
Tommy's right.
b from both sides. We can also work with our numbers at that same time. We need to get 80 to the right side. So what
Plus.
should I do to 80? Add 80.
Más 80.
Okay, b squared minus 20b. Again, these are not like terms. They do not combine. You just write them side by side. And then the weird spot is we have to remember to put in our blank spot. You don't technically have to write it in, but I think it's a good visual cue so you remember where we're going with it. On the other side, we actually combine these. 20 plus 80 is 100. And then we need a blank spot on both sides because what you do to one side, you do to the other. So then we had to do our completing the square process. We take our middle number, 20, and what did we do to the 20?
Subtract it.
Square comes second. Divide by 2 comes first. Okay, we need to divide by 2 first. Put that number in our perfect square binomial. So the 10 went down there. And then we square it to get the blank spot. Then we get negative 10 squared is 100. So what we add to one side, we also have to add to the other side.
Negative 10 squared. It's 100.
So if we combine those together, we get
200.
200. 100 plus 100 is 200.
200.
I'll give you one.
Okay. Now we're trying to get b alone. So how did we say we got rid of squared, Hannah? Square root it. The 2 and the square root cancel.
So did the parentheses on it.
And so do the parentheses, yes. I usually just drop them and I don't actually cross them out, but you can cross them out so you know that they're gone. And then I had to put a special symbol in front of my square root.
Plus or minus.
Plus or minus. Square root of 200. And we could simplify the radical now, but I feel like it's better to do all the first 5 steps the same way and then just have the one variation at the end. But if you wanted to, you could simplify the radical now. But I'm going to take care of this 10 first.
You add 10.
Add 10 to both sides. So we get b equals 10 plus or minus 200. So if 200 didn't simplify, we'd be done. But 200 can simplify. So now we have to do our factor tree. We have to go back to what we learned first quarter. 20 and 10 is a good place to start. 20 times 10 is 200. Then we keep factoring. What are some things that multiply to be 20?
5 and 4.
5 times 4. And 4 can be 2 times 2.
I got it.
10 is 2 times 5. So again, this process we've been doing a whole lot in first quarter. We did it the very first day you were here, and then we used it throughout the quarter. So we end up with 2 times 2 times 2 times 5 times 5. And what size groups am I looking for?
So you weren't.
So 2. Yes.
When you added 10 to both sides of there,
Mm-hmm.
do you add it to the symbol or square root?
This 10?
Yeah.
Okay, since it couldn't combine with this, we just wrote it side by side. Since they weren't alike things, like this is not a square root, we can't combine them. And even if it was a square root, they'd have to be the exact same number under the square root to combine it. So we just put it out front. So we bring 1 out, 1 dies, so we have 2 times 5 out front. We had a 2 left inside. Then we actually do the multiplication. What is 2 times 5? 10. So that was all just to simplify this thing, so we still need everything else that we didn't do anything with. We still need all the rest.
Oh my goodness.
To go out front. So we get b equals 10 plus or minus 10 square root 2. Okay, so we need one more example because there's going to be one more variation on this simplifying process. But I'm going to have you start the example.
What kind of people do this math?
Nobody.
It depends on your job. Engineers would use math like this. Physicists. Any?
Computer programmer.
Really? Actually, yeah, the military would use quadratics if you're...
You kidding me? Now I'm not going.
It depends on what part. But when you're aiming artillery, you need to know some trig and some quadratics to aim stuff like
Now they
that.
have like little things.
I'm learning that, so...
No.
Like I know the ways and all that.
Yeah. Hey, need everyone's attention up front. Sophie, what should I do first?
I do not know.
Danny, what should I do first?
What should he do first? Minus
Chris?
10.
Minus 10.
The one time I also didn't say it.
Yes.
Okay. Before I write the equal sign, what should I write?
A blank sign.
Blank spot. And then we actually subtract 22 minus 10 is 12. Then we have to complete the square. We have to divide the middle number by 2. We still have too much talking. We just need like 3 more minutes of quiet. Okay, so Daniel said to divide by 2, which gives us x plus 2 squared. And then we have to square this number to get this blank spot, which would be 4. What we do to one side, we have to do to the other. So what does x plus 2 squared equal? 16. Then I have to get rid of squared. How do I get rid of squared? Square root both sides.
Wait, Miss Barbie?
How did we get 16?
Yeah, that's
How did we get 16? People are asking. Okay. We actually added these numbers together. 12 plus 4
I'm hungry.
is 16. So we square root both sides, which leaves us just with x plus 2. What do I have to write in front of my square root?
plus or minus.
Plus or minus. Some people simplified the 16, that's fine. I'm going to wait till the end to simplify. And then how do I get rid of the 2?
Minus 2.
Minus 2 from both sides.
What do you get that right now?
Okay, now we can simplify. What do we notice about 16?
Perfect square.
It's a perfect square. What's the square root of 16? 4. So pretty much everyone got to here. Well, not about half the class got to here that I checked.
I just said it wrong.
There's another step on this one.
Wow.
This one has a variation. What do we notice about these two numbers now? Negative 2 and 4?
They can add together.
They could actually add together. So remember, this plus or minus was two things. Sade, Chris, we just need like 1 more minute of quiet.
Okay.
1 more minute.
Yummy.
It was two things written as one because mathematicians were lazy. That was all that they wanted to do was not have to write something twice. But since we can combine this, we need to write it twice now, so we could. I'm going to write negative 2 plus 4, negative 2 minus 4. We have to do it twice because they could combine. With the square root, they don't combine, so there's no point in writing it twice. If we write it twice, it stayed the same. But these will combine and change to be 2 and negative 6.
That's our answer.
Those are our two final answers for this problem.
How'd you get the minus 4 though?